Okay, so this is going to be a quick video to show you how to find percents that don't fit in the 68, 95, 99.7. I don't have a calculator right now that's connecting to my computer, so I'm going to have to show you pictures and you're going to have to kind of follow along. But first of all, we just have to remember and know what our standard normal curve is. We haven't talked about this yet, but the standard normal curve is when your mean is 0 and your standard deviation is 1. So it's a capital N 0, 1. This is what we're going to use when we talk about z-scores, because z-scores are how many tick marks away something is from the mean, and so we will always use this. I don't know how I go over just one. Hold on. So for a standard normal curve, the mean is 0, and then your 3 tick marks to the right and 3 tick marks to the left are just 1, 2, 3, -1, -2, and -3. Okay, so that's what's going to happen when you have a standard normal curve and when we're talking about z-scores. So remember here, 1 deviation to the left and right, it gives you your 68%, and then 95%, and then 99.7%. Okay, if you haven't watched that other video, you might want to before you go on with this, because otherwise it's not going to really make sense. Okay, so let's say my numbers don't land exactly at my standard deviation, which is going to happen majority of the time because stats is real life, and real life doesn't end up perfectly. Okay, so to find percents not represented, the first thing you're going to do is you're going to find your z-score. And remember, you find your z-score by doing your mean or your value. Change that. Your value minus the mean, I didn't want it to get confusing, over the standard deviation. Okay? From there, you're going to draw and shade a curve. Okay? And then what you're going to do is you're going to do the calculator steps. And I'm going to show you pictures of the calculator, and we're going to write it down so that it can kind of make sense. Okay? But we're going to add some more down here, so just leave that blank. Okay? All right, so let's go ahead and start a problem. Okay. So the first example we're going to do, I'm going to change colors, is let's say the average weight of a cat is 8.9 pounds. With a standard deviation of 1.3 pounds. And I did look that up, so I think that is the accurate amount. So if we look up above, it says step 1, find the z-score. Okay, so this cat is 7.2 pounds. I'm going to minus the mean, and I'm going to divide by the standard deviation. So 7.2 minus 8.9 is -1.7 divided by 1.3. And so that gives me a z-score of -1.31. Okay, so now I'm going to draw my curve. Oops, that's kind of ugly, but I'll do that. So the mean cat is 8.9 pounds, and it weighs 7.2, which is over here. Okay, I'm going to do this based off my z-score, which is right here. Okay, that's how many tick marks away. It's 1.31 tick marks away. Now, it says under. So under is everything to the left. It's smaller. So that's my shading. Without shading in a picture, you're not going to get full credit. On the AP test, that would be the difference between getting full credit and partial, just for a little picture. And the same thing on my quiz and test. I have to see a picture where you label the mean, you draw your bar, and then you shade which side I'm going to. And because it's under, smaller than 7.2 pounds is on the left. Okay, now that we have our picture drawn, we're going to go to our calculator. And this is the best I can find with my resources I have. So I need to do second distribution. Distribution is right here. You can't see it. You could see my mouse moving. Second vars. I'm going to hit second distribution, and this menu is going to come up. And I want you to choose number 2. This is normal CDF. CDF stands for cumulative. So it's our normal curve cumulative percent. Okay, so excuse me, second distribution, and then I go to normal CDF. And when you hit this next screen is going to pop up. Okay, what happens next is this normal CDF screen pops up. If this does not pop up, it's because your calculator has not been updated. If you get this screen when you use use your calculator and hit second distribution and go to normal CDF, you'll do this process. If you don't get this screen, just hold on and I'll show you the other process. Okay, so this is important for all of you though. So lower is just something on the left, which is way over here. I highlighted it green. Okay, so I need my lower number to be much smaller than everything else, and so I'm going to cross this off or delete it, and I'm going to do negative 99999. That's really to the left. The upper number is where the line is, and my line, my line is right here, which is at that standard deviation of negative 1.31. My standard deviation, or my mean, and my standard deviation remain 0 and 1. And so my lower is a really small number. My upper is my z-score, because that's where my line was. And my mean is 0 and my standard deviation is 1. And you go down and hit enter, and what you get is you get 0.095, which means that 9.5% of cats weigh under 7.2 pounds. Okay, now if this screen doesn't pop up, you still have to answer these questions. You just have to remember the order. And so when I get back, I will update the calculators, and if you have a library calculator that's not updated, I'll update it. But I still do my normal CDF, but then I have to know the order. So it's my left number, my right number, which is my z-score, I don't know why I put a 6, my mean, and my standard deviation. So this is left, right, mean, and standard deviation. And again, I am using 0 and 1 because I'm talking about z-scores. But it's the same idea. 9.5% of cats weigh below 7.2 pounds. Okay, for the next one, now I'm going to do the same thing. Cats that weigh more than 10 pounds. So I have to start off by finding my z-score. So 10 minus 8.9 divided by 1.3 is 0.846. So now if I drew my normal model, and I'm going to actually use 0 and 1 because I think that was confusing up here. I am 0.846 z-scores away, but you see this, it says more. So this time I'm shading to the right. Okay, so now you hit your second distribution, and this screen pops up. My lower for this time, lower is left. And so the left side of this shaded region is my z-score for this one. So 0.846. My upper, I need to pick something way over here, way to the right. So I'm going to pick a, like, I don't know, 10,000. And it has just to be big. It has to be way to the right. And my mean is 0 and my standard deviation is 1. And once you get that plugged in, 846, I find that 19.9. So only 19.9% of cats weigh more than 10 pounds. That's what that says. Only 19.9% of all cats weigh more than 10 pounds. And again, if you don't have this screen popping up, you'll have this screen, and you just have to remember it's the left. And on this one, the left was our z-score. Then it's the right, or the upper, which we just picked a big number. And then it's the mean, which was 0, and the standard deviation, which was 1. I don't want to put a line above it. Okay? All right, last one, same idea. This time, I have an in-between weight. So I have 2 z-scores I have to find. Okay, so 7.5 minus 8.9 and 9.9 minus 8.9. So the one on the left is negative 1.08, so that's over here. Negative 1.08. And the one on the right is 0.77. So that's right about here. And now it says between. So for between, I shade in between. Okay, so now I'm going to erase these things over here because I want to find what percent is in between. And so, again, lower for this one, my lower is my left, which is negative 1.08. My upper is this right here, which is 0.77, and my mean and my standard deviation stay the same. So second bars, and so it's 64%. I don't know why I did that. Hold on. So it's 63.9% of cats that weigh between 7.5 and 9.9 pounds. And so this one was negative 1.08 because that's the left side. And then 0.77 because of the right side. So draw your so find your z-score, draw your picture in shade, and then you have to do your normal CDF. Remember, lower is left, upper is right, and if there isn't a number there because there's not a line, you have to pick a very small number or a very big number. And I'm sorry that it might have been a confusing video because I didn't have access to a calculator, but after practicing in class today, you should be okay.